Welcome to the 6.3 Logarithms and Logarithmic Functions Notes, Part 1. By the end of this lesson, we will be able to answer the essential question, what are some of the characteristics of the graph of a log function? So everything we do today in the next couple of videos will be to set us up to what do we know about log graphs. So the first thing we need to do is, what is a logarithm? And a logarithm comes from the need to solve for an exponential function. So for example, we can talk about things like 4 squared equals 16, or 4 cubed equals 64. But 4 to the what power is going to give us something that will make 50. So I know that it has to be 2 point something because 4 squared is 16 and 4 to the third is 64. And 50 is somewhere between 16 and 64, but I don't know what. It's going to be 4 to the 2 point something power. Well, what is that something power? And so logarithms were created to help us with that situation. So logarithms are coming from the need to be able to solve for an exponential function's variable in an exponent. So that's why this part of our definition exists. B to the x power equals y. So if we were to start with an exponential function like y equals b to the x power and find the inverse to it, how is it that we find an inverse? Well, remember, the first step in finding an inverse is to switch the x's and y's. So x equals b to the y power. And now we have to solve for y. How do we get that variable out of that position? Well, that's where a log function comes from. So we can now say log of base b of x equals y. So being able to write it from exponential functions to a log function is how we're going to be able to solve for that missing exponent spot right there. So that's why we need to have logarithms, because we are unable to solve for exponential functions any other way. And the big idea behind this is that exponential functions and logarithmic functions are inverses of each other. And one thing I do want to talk about here is it says that log base b of y. This is how you're going to pronounce it. Log base b of y. And while I'm here, let me talk about when you were in kindergarten, you learned how to write on paper that had lines like this. So when we write the word log base b of y, I want to show you that log is written on the normal line. Base b is a subscript and it's tinier and lower. And then whatever the argument is, the thing that we're talking about, log base b of whatever, that's a normal size in your printing or writing. Now I like to use the cursive L so it doesn't get confused with a 1 or a capital I. Okay. The other thing I want to share while we're talking about these notes here is, oh, I forgot, so I'm going to keep going and then, oh, now I remember. Log base of your answer is going to be an exponent. And this will help us when we need to start rewriting things. So if this is one of the things you can commit to memory, this will help you when we need to rewrite from exponential functions to log functions. All right, so as I scroll down in OneNote, here we are, we're ready to rewrite these exponential functions. So let me switch colors here. So remember that an exponential function is, this is your base to the exponent equals your answer. So 2 to the x equals 8. Now I just had written higher on the page, log base of your answer equals your exponent. So in order to write 2 to the x power equals 8 in log form, what's our base? So log base 2, what's our answer? 8 equals x. And so that's how you're going to rewrite an exponential form. So let's take a look at our next example here. I'm going to change colors. 3 to the what power equals 9. So remember, this is going to be log base. Our base is 3. Our answer is 9. So of 9 equals x. Number 4, again, log base, log of your base of your answer equals your exponent. So log base 4 of your answer 2 equals your exponent, x. So you try number 4. 5 to the x power equals 1. Did you get log base 5 of 1 equals x? Okay. Log base, what's our base? 5, what's our answer? 1/5 equals, what's our exponent? X. Okay, try number 6. You should have log base 8 of 4 equals x. So that's how we do the rewriting. So let's make sure we've answered all the questions here. Find the value of x in each exponential function, explain your reasoning, then use the value of x to rewrite the exponential equation in its equivalent logarithmic form. So we do have exponential form to log form, but we need to evaluate these. So we need to go back and say to ourselves 2 to the what power will give us 8. So 2 times 2 times 2 is 8. So 2 to the third is 8. So that means x equals 3. Number 2, 3 to the what power gives us 9. Well, 3 times 3 is 9. So 3 squared is 9. So in this case, x will equal 2. Now, how are we going to do question number 3? 4 to the what power is going to give us a 2. In this case, 4 to the what power will give us 2. I happen to know that the square root of 4 is 2. And in chapter 5, we will learn that the square root is really the 1/2 power. So in this case, 4 to the 1/2 power equals 2. So x will equal 2. Number 4, I'm hoping you guys were able to figure this out. 5 to the what power will give us 1. Almost anything to the what power will give us 1. What causes us to have a 1? And I'm hoping you guys are thinking 5 to the 0 power equals 1. So in this case, x equals 1. And in number 5, what causes a positive base of 5 to flip over and become a fraction? I'm hoping that you were thinking it was a -1. And then on question number 6, this is a problem because at the moment we have skipped chapter 5. We haven't really talked about these kinds of problems. But let me tell you that it is going to be x is equal to the 2/3 power. And that again isn't something chapter 5 we will visit shortly after we do chapter 6 here. But for now, all you need to know is that 8 to the 2/3 power will give us 4. All right, and questions 7 through 12, it says rewrite the exponent or the equation in exponential form. So again, we're going to use that idea of log of the base, log base of your answer has to equal your exponent. So what's our base for question number 7? So our base is 10 to the what power? Here's our exponent. So 10 to the third has to equal 1,000. And I hope you're saying to yourself 10 times 10 times 10 is 1,000. Okay, question number 8. 5 to the -2nd. It's 5 because that's my base. This is my exponent. Has to equal my answer of 1 over 25. Now let's think about this. What does a negative exponent cause us to do? It causes us to create a fraction. It's reciprocal. So 1 over 5 squared is 1 over 25. Okay, number 9, log base, our base is 3, to the exponent of 3 is going to give us an answer of 27. Number 10, go ahead and give it a try. If you need to pause the video, go pause the video and then come back. Okay, our base is 10, the exponent is 0, and our answer is 1. Question number 11, the base is a little funky on this. Do not panic. The base is 1/4. Let's put it in a fraction. To what power? -3 will give us positive 64. So remember, a negative exponent causes the reciprocal, so 1/4 just becomes 4. 4 to the third is indeed 64. And question number 12, 4 to the -2 equals the answer of 1/16. Let me take a moment here and talk to you about exponents. When we talk about, let's see, 4 to the negative, I lost my train of thought again. I'll come back to it because I know I'll end up discussing it with you anyway. So I'll remember in a moment and get back with you. Let me end part 1 for now.